Okay, I think we can start now. We can start now. So let's stop sharing the QR code. And okay, so before that, if I'm not mistaken, you are just submitted. You just submitted your assignment number. I don't remember assignment number 9. Yeah, sorry, number 8. Assignment number 8. So let me show you. Let me show you. The e-learning portal for assignment number 8. Okay, so okay, I think you submitted. You submitted. Now I have posted all the solutions. All the solutions, including how I solve question number 5 of assignment 8 using ANSYS. Using ANSYS. Okay, so this will be a good example for you to start your project. To start your project, because your project, which is this one, is based on CST. It's based on CST. Okay, it's based on CST, which is this one. So the topic is constant strain triangle. Constant strain triangle. So basically, you have about 1 month to finish this. About 1 month, starting yesterday. Okay, 1 month, and you have 3 of you to do this. Okay, some of you have two members, two team members. Okay, if you have only two members, then I think you need to work harder than the one with 3 members, lah. So this is the project, and let's go about the project, one by one. So hopefully you know what I meant, what I want from the project. So you can use this video as a guideline or as a method. Okay, again, I think I mentioned to you that you need to download ANSYS, and I've given some examples here. Okay, this is where you download the ANSYS software. This is how you do beam element with ANSYS, and this is how you use frame element for ANSYS. And now this is how you use CST elements for ANSYS. Okay, and that will be, I think, helpful for your project, for your project, which is this one, which is this one. So note that this is a 3-member group project, not more than 3, not more than 3. 3 is maximum. Some of you have 2, but I think I prefer 3 members. Okay, this is a 3-member group project. While discussion with other group is encouraged, all works submitted for credit, however, must be your own. Saya tak nak, I do not want, there's 3 people and there's another 3 people doing the same project. No. So you have different project, you have different project. So let's say group 1 and group 2, they have 2 different projects. Okay, so must be your own. Any evidence of plagiarism or other form of scholastic dishonesty will be ground for failing grade. So saya akan bagi 0 for your project. This happened before. This happens before. Student copy some of the papers from internet, and he or she did not understand anything. Okay, so I gave that group a 0. Okay, so now goals of the project, to do finite element analysis manually. Okay, because we learn how to solve CST manually. So we derive everything. And then we can use that method. Software package. I think the assignment only asks for this assignment. For assignment 8, it asks only for 2 elements of CST, because when you have more than 2, then it becomes more tedious to calculate. More tedious to calculate. So at least this assignment has introduced you to 2 elements using CST. Alright, so to verify, okay, to do finite element analysis manually without any finite element method, software, package. So in this case, we are going to use ANSYS, but at the same time, we are going to use manual approach. It is hoped that students can realize that FEM software package is just an automation tools for the manual analysis. Okay, because if you look at the manual method, you have to calculate the element stiffness matrix for element number 1, element stiffness matrix for element number 2, and so on, and then assemble. But using software, this is automated. It will be assembled using the software, using the software. So this is what I want to show you basically. So to verify and compare results obtained using manual and software analysis. Okay, any result, discrepancies between the two approaches should be identifiable and justifiable. Okay, so if you notice that the answer is different from your manual and your software, then you should know what's the reason, and you can justify the reason. Okay, this is why. And then to recognize that FA model can be simplified due to model symmetry by applying the appropriate boundary conditions. So this case, we do not need to use for this problem here. You do not need to use uh, the whole model. You can use, in this case, quarter model. Okay, to recognize that the FA model can be simplified due to model symmetry by applying the appropriate boundary conditions. Okay, the typical simplification is either half or quarter model. So let me give you a clue. For this project, you can use a quarter model. You can use a quarter model, but you need to assign the correct boundary conditions to be able to communicate theory, methodology, result, conclusion of finite element analysis orally and in written form, which means you have to present your result orally, presentation, and of course in term of written form, which is a report. Okay, a report. So this is the whole idea of your project, and that is why I think 3 students. Okay, it's not 1 or 2 students, but 3 students. I think this is a lot of work. Kalau seorang tak susah sikit lah. So we need 3 students for this. Alright, so this is the one. This is I taken this from I took this from Shigley. Shigley. So this is your K, your stress concentration factor. And note that the dimension involved here is R, W, and D. So let's say R over D and W over D. These are the parameters. So in the case of R over D is 0.15 and W over D is 1.1, then this is about maybe 1.9. Okay, maybe about 1.9 or 1.8. Sorry, 1.9 or I don't know, maybe 2.0. Okay, not sure. Okay, so this is what we want to do. So what we want to do is to model this using finite element, and hopefully we get the same answer as our K here in the table. Okay, figure A notched thin plate with thickness T, stress concentration factor KT, and material properties is E equal to 0.207 gigapascal, and Poisson ratio of 0.3. Okay, first part is derivation of formulas. I think derivation of formulas is not an issue because you have done this in assignment number 8. Okay, you done this here, right? So you just then copy and paste and put it in your report. Okay, so basically this is a free gift. Okay, derivation of formulas, you have done it in your assignment number 8. So no issue here, no issue. Okay, now the next thing to do is analysis using software, ANSYS. Okay, this is where you might want to refer to my video on this one. This one here. This one here. So hopefully you can see this is the one. This is a CST using ANSYS. CST using ANSYS. So this is the video. This is the video. Alright, so you can use that as a guideline, okay? Or maybe you can find a better video on YouTube. Okay, just like I mentioned before, I'm not good at ANSYS, but I think I can do just fine untuk simple problem. But if you need advanced, you might want to go to YouTube and find a better video that explain CST using ANSYS. Okay, so since the plate shown in figure 1 is symmetrical in both horizontal and vertical axis, the analysis can be done by using quarter model with appropriate boundary condition. Use a minimum of 12 triangular elements. Okay, the problem with ANSYS, it can use either rectangular or triangular. Okay, so I think rectangular elements we do not cover in this class. So what you need to do is to see my video how I tweak in such a way that I want ANSYS to only use triangular element, not a combination of both triangular and rectangular. Okay, or what they call quadrilateral. So this is what you can refer to this video and you can see how I tweak in such a way that it will only use triangular element. Triangular element. Okay, use minimum of 12 and by identifying all boundary conditions, do a finite element analysis on the quarter model of the plate. Okay, so this is the one. So quarter model means you cut it here and you cut it here. So then you have a quarter model. Then you have a quarter model, not the whole model, because it will consume your PC time. So what you want to do is to reduce the computation. Computation. So in this case, you might want to use this. Okay, so maybe you cut it in half. You cut it in half. So you might want to use one of the quarter model. You can use this one, you can use this one, you can use this one, or you can use this one. But the boundary condition must be appropriate to this model. Okay, next is manual analysis. Remember that for this, we need to have 12 CST elements. 12 CST elements. So now what you want to do is to use manual analysis. So basically, for the manual analysis, you need to find all the stiffness matrices, all the stiffness matrices for all elements. Element 1, element 2, element 3, element 4, and so on. Okay, so this will be huge. This is huge. So repeat question 2 using manual calculation by answering the question below. Use Octave. Use Octave to solve large SLE. If you have 12 elements, what is the size of this? What's the size of that one? I have no idea. Okay, so it must be huge. It must be huge. This one must be huge. I don't know. Okay, so is it 36? I don't think so. It's slightly less than 36, I guess. Slightly less than 36 because one element has 3 nodes, and then we have 12 elements. Then 12 times 3, 36. But there are some overlapping nodes. Overlapping nodes that you have to consider. Okay, so this is the one. This is the one. Use Octave to solve this SLE. Use double precision and carry at least 10 decimal place precision for all calculations, because nanti what happens is that because of you are using less significant figures, your answer will not be the same as the one in your ANSYS result. So the first thing that you need to do is to extract coordinates. Extract nodal coordinate. Okay, I don't remember if I showed this in my video, but you can take a look the coordinate for the element. For example, this. For example, this one. Okay, I know what is this node. I know what is this node. I know what is this node from the input file of ANSYS. ANSYS will tell you what are these coordinates. For example, maybe this is element number 1. This is element number 1. Okay, element number 1. This is element number 2. So you can take a look at the files. Okay, we tell you what are the coordinates for element number 2. Okay, so there's no issue here. There's no issue. You can extract the nodal coordinates, but I don't remember if I have that in my video. Hopefully I have. Hopefully I have. Okay, so we can find all the coordinates for all the elements. Okay, using the nodal coordinate, draw each element to complete the quarter model. So you have to draw manually lah. Considering all boundary conditions, manually determine the stiffness matrix for each element. Okay, manually. So we have K1, K2, K3 until K12, and then determine the load vectors for each element. Element 1, element 2, element 3, and so on. And then build the global stiffness matrix. Global matrix for assembly, the element stiffness matrices, and load vectors. And then what you get is K, Q equal to F, and then solve for Q. Okay, solve for Q. Okay, use Octave to solve all displacement, unknown displacement. Please submit Octave file. I want the Octave file as well because I need to test. Okay, compare your displacement for point A, B, and C. Okay, A, B, and C with the one from ANSYS result. Okay, so this is A, this is B, this is C. So I want you to compare the result from ANSYS for A, B, and C, and the result from your manual calculation A, B, and C. Theoretically, it should be the same. Theoretically, okay, theoretically it should be the same. But if you screw up, then it will not be the same. Okay, so let me give you a hint here. It should be the same because the formulation is the same. Okay, the number of elements is the same. The coordinate, the nodal coordinates are also the same. So it should be the same for displacement at point A, B, and C. Okay, and with the ones from answers, are they the same? Explain. Okay, I've given you the clue. It should be the same, and explain why. If it's not the same, then of course, explain why. Okay, now we have done that. So we have done ANSYS, we have done the manual. So ANSYS with 12 element, manual with 12 element, and using Octave to solve for the SLE. And then now the fourth one is analysis using ANSYS for further improvement. So we know that if you use more elements, our result will become much better. Our result will become much better. So now the question is, how many elements is considered as optimum numbers of element to use? Is it 12? Is it 30? Is it 40? Is it 100? Is it 200? Is it 1000 elements? Okay, so this is the question. You should be able to answer this. You should be able to answer this. Okay, how do you determine optimum numbers of element? Okay, so basically these two questions are related. These two are related. Okay, determine the displacement, strain, and stress at point A, B, and C. Are they the same as in question number 2? Okay, note question number 2 is using only 12 elements. It's only using 12 elements. Okay, but question number 4 is using optimum number of elements. So which one is more accurate then? Is it the one with in question number 4, or is it in question number 2? I hope you know the answer. I hope you know the answer. So this is the question. Okay, explain. Are they the same in question number 2? Explain. From result in part C, this one, determine the Poisson ratio. Okay, what is Poisson ratio definition? You might have to look at your solid mechanics textbook. What is Poisson ratio? Is the calculated Poisson ratio value the same as the one used in the analysis? Okay, because we use Poisson ratio of 0.3. So do we get the same answer as the value that we use? Okay, so this is part D. Is the calculated Poisson ratio the same as the one we use? Calculate the stress concentration factor using this formula. Okay, so sigma max is from FM analysis, sigma max, and sigma naught is just F over D over T. D times T is basically just your D over T is just your it's just your area. It's just your area. So let's say this is the one. So the thickness is T. Okay, and the area here is D is basically this. Okay, minus this. Minus diameter of the hole, because this is the area that we are interested in. Okay, so these are the area that we are interested in. Okay, so again, this is the area that we are interested in. All right, compare the KT with the one from figure 1 and comment. So do we get the same answer as the one in figure 1? Okay, because this value, they get it from experiment. They get it from experiment. So what we are trying to do here is to verify using a finite element. So are they the same or not? Okay, so identify and discuss any discrepancies in the results. Okay, recommend ways to improve the analysis and eliminate discrepancies. Any problem with errors basically, discrepancy, perbezaan. Okay, report project submission. Solution and answer to this project must be presented in standard technical format, formatted according to UTM thesis manual. I'll give you a copy of thesis manual later. I'll give you so you can see how to use this. Maybe I can talk a little bit about how to use the UTM thesis manual. By the way, I think after this you'll be going for your Latin industry, kan? Then after that you'll be starting your PSM. Okay, anyway, it's good to have an early start on how to use the template of your thesis. So these are the topics: introduction, problem modeling, FE, discussion, and conclusions. These are basically the chapters in your report. Octave and file used for calculation, and any report soft copy must be submitted. No mark will be given if the soft copy is not submitted. Okay, I need to see the soft copy. Macam mana saya nak tanda kalau tak ada soft copy, kan? A project grading session with randomly selected group will be held to discuss about the submitted projects. I'll pick any random group, okay, and I'll call them so that they can explain to me what they did for project. Okay, what they did for the project. So I need to know if they really doing it. Okay, so this is the number 3. And number 4 is please include the following statement in the first page of project submission. Do not use fancy fonts as your signature. Signature, you use your pen, sign, scan, and put it in your report. Put it in your report. So this is the declaration. Declaration. So again, if this is not included, no mark will be given. Again, every semester ada group yang tak akan submit dengan this one. I don't know why, because I keep explaining all this. They have all these question papers, but yet they still cannot follow the instruction. Okay, so I don't know why. Okay, that is the report. Now we have project presentation here, 5%. So the total here is 15%. For presentation, each group will have to prepare a presentation, 10 slide maximum, excluding title and slide. So you will talking about introduction, explanation, and conclusion. Every member of the group must present. Everyone, kalau ada tiga must present. Okay, so everyone from the group must present must do the presentation. Okay, and then we have peer review. Peer review ni, the issue with peer review, lately there's let's say we have 3 people. Other one of the members is not doing anything. So he got the same mark as the rest, which is to the others, it is unfair. I agree. You do the hard work, and this guy, which is a freeloader or free rider, get all the marks, which is not very good. Okay, I mean not a good action lah. So we will do the peer review. So in this case, we have 3 members. Member A, member B, member C, and a scale from 1 to 5. So what is the punctuality? So this guy is always punctual. Okay. Member B is always punctual. This is the good student lah. 5, 5, 5, 5. But this one is not as good. 4, 4, 4. This is the bad student. 2, 2, 2, 2. Note that the weighting factor for the bad student is only 0.5, and the member mark is 0.5 times whatever the group will get. Okay. Let's say the group report is maybe 80%. This student will get about only 40% because of this. So please make sure everyone is cooperating. Everyone is doing the work. Okay, am I still online? Hello?
Yes,
Alright, because tadi dia stuck. So I was afraid because my internet connection is not stable. So that's the issue. So this is the one. This is the one. Okay, so remember, weightage. Okay, every semester akan ada complaint from one of the team members lah. Dia akan kata, Doctor, that guy is not doing anything. He got the same mark as me. But the whole thing is done by me. Dia seorang aja buat. The two are not doing anything. So this is unfair kan? This is unfair. So we put this peer review. So please, when you do peer review, please be honest. Please be honest lah. Jangan nak tolong kawan kamu tu. Kalau dia tak buat, tak buat lah. Okay? Kalau dia tak buat, tak buat. Letak situ satu. Tak pernah datang meeting. Kosong. For example. Okay, now, ada lagi. Okay, these are the parameters for each group. Tadi talk about R and D, W over D. So alpha, beta, gamma sampai tau. Yeah, by the way, this is what we call the Greek alphabets. So we are currently at this location kan, Omicron. Before this, we were at Delta. Masa tu tak ada ubat lagi, no vaccine. Now we are at Omicron. Okay, hopefully not going to be more lah. Okay, so they skip Z. They skip mu and new. Okay, they skip that. Because Z is a Chinese surname. So dia tak nak lah nanti orang kata apa ni Chinese surname ni yang buat vaccine. So that's why they skip. Okay, so R over D is 0.2 for alpha and W over D is 1.2. So you know what you need to do lah. You need to know. Okay, this is the one. So W is this, D is this, R is this. Okay, so this is the parameter for each group. Okay, I noticed that some of the group is still empty. I don't know what happened because for your information, I do not have a record who dropped this class. Okay, I do not have the record. Okay, I do not have the record because lately ni kita punya aim swab is having problem. Even though you registered, sometimes it's not telling you that you are registered. Sometimes you do not register, but your name is there in my list. Okay, and my issue here is ada student registered, Okay, tapi tak pernah buat homework, tak datang ujian tapi tak pernah hantar, and yet dia still ada dalam kelas ni. Saya pun tak tahu dia ni status macam mana. Okay, so these are some issues yang saya bermasalah lah. So that's why saya biarkan saja sampai tahun ni. So because this is the total number of group untuk our total number of students. Okay, total number of students. So please please follow this table for your group. Please follow this table for your group. Okay, now this is the rubric. This is the rubric. So what do you need have to score the best score lah? Okay, I give you the rubric. So introduction. Excellent is this. Identify suitable problem, recognize the issue correctly, simplify them into the best way. Okay, so I expect this in your report. Okay, and this one is poor. No clear relevant problem is identified. I can show you some of the report. Tiba-tiba je ada analysis, tak ada introduction. Okay, this is another way of not good technical writing lah, yeah. Not good technical writing. Okay, I have I have copies of my report that I submitted to my client before this. Submitted to Petronas and some other clients when I was working as a consultant dulu. Ada. Okay, so the whole idea of writing this report supaya this client, in your case, I am your client. Jangan ingat saya faham apa yang kamu tulis. Just assume that I am nobody. You need to explain to me every single one. Don't treat me as your lecturer, but treat me as your client. So you will write nicely, you will write clearly, so that I understand what you are telling me. Okay, so in this case, what you want to do is to look at this column lah, column yang 80 to 100%. This is what you want to look at. Do not look at this one lah. This is for not good lah. Do not look, or even this one. Okay, please take a look at this sahaja. Okay, so this is for the report, and we also have for the presentation. Again, oral presentation, all members must present, because that's marked to it. That's marked to it. Again, what you want to see is this. Okay, an easily understood presentation in clear voice, addressing the audience with confidence and grasp of the issues. Saya tengok muka blank aja, tak confident aja. Dia nak explain pun dia tak pandai. Then it might not be this thing lah. It must be this here. Confused presentation, rambling and unsure of the topic presentation, and barely audible. Cakap pun cakap dengan diri sendiri je. Orang lain tak dengar. Okay, so these are the rubric. These are the rubric. So I hope I've given you a very clear what is the expectation of the project. Okay, I have given you the rubric so that you can score the best score possible. The best score possible. The problem is, this is funny. Last semester, there's one group. He contacted me. Sir, I cannot submit. I told him, because the submission is already closed. How can you submit? Because it's already closed. Half an hour late. Okay. So he submitted through Telegram. And I take a look at that project, and I told him, this is a project that you wrote last night. This is not last 4 weeks, I kata. So I noticed that the quality of the work is very poor because this group keep waiting for the last minute to do it. Okay, so no, please do not do that. I'm trying to help you. I'm trying to get you more marks. Okay, I keep reminding. Bila saya keep reminding, you know what the student comments? The student in EPPP, dia kata, Dr. Fuad is micromanaging. Saya kata, saya bukan micromanage. I'm trying to help you. I keep reminding you so that you can do the project. Very good. That's the whole idea. Okay, bukannya saya nak micromanage. The whole idea is to give you more marks. That's the idea. But student ni complain, dia kata, I am micromanaging. I said, no, I'm not micromanaging. Okay, so that's the idea di sini. So please plan your work. Buat Gantt chart semua tu. Buat bila nak buat apa, bila nak meeting. Okay, buat minit-minit mesyuarat tu, all the minute of meetings. Okay, included in your reports. And I will know siapa yang tak datang. I know who absent during the meeting. Okay, so that is one of the reasons that you have to have minutes of meetings. Okay, so this is the project. This is the project. And note that the due date is on the 4th of June. 24th of June. 24th of June. Assign 24th of May. Bila dia punya due I think due date dia lah dekat sini Due date dia dekat sini 26 June. 26 June, about 30 days from or 1 month from today. Because after that, you have 1 week for your study break. So the school has instructed all the lecturers to not do the project during your study break. Okay, during the study. That's why I stopped at 26 of June, because the next week, which is I think July, then it'll be your study week, your 1 week study week lah. So that's why I said it's 26th of June 2022 before 5 p.m. So what do you need to submit? The report file in PDF, Octave script in .m format. It's similar to MATLAB. Please do not use MATLAB. I do not have MATLAB. I do not have MATLAB on my PC. Okay, because MATLAB you have to have a license. You have to connect to the license through UTM. Okay, so I do not have MATLAB. So I'm using Octave, which is sort of clone of MATLAB. But it works as good as MATLAB. Okay, PowerPoint presentation slides in PPTX format. Okay, and due date is 26. So there are 3 files that you have to submit. Yang ini pun ada pelajar, saya pun tak faham macam mana dia start baca ke benda ni. Ada pelajar dia submit cuma 1 saja. Okay, so I do not understand what this kind of students are thinking, because before you submit, there's the announcement here that you must submit all these 3 files. But okay, over and over every semester, there's a group, 1 or 2 groups will only submit 1. Just the report. Okay, just the report, which is unacceptable. Which is unacceptable. Okay, please do not do this kind of silly mistakes lah. This is a very simple instruction saja. This is a very simple instruction. And again, please start as soon as you can lah. Start sikit-sikit, tapi by the end of the day, by the end of the due date, you can finish. Do not start at the end and to expect to finish. No. Macam student yang saya kata itu, dia started I think last night. And this morning dia nak hantar, and then dia tak boleh hantar because sistem dah tutup. Okay, at the end of the day, saya kata saya tak boleh terima because I cannot see your reasoning. I cannot see your reasoning kenapa lambat. Okay, dia lambat sebab dia start lambat. Itu isu dia. Okay, please. Alright, so any question on this project? Any question on this project? Any question? Okay, I hope this is very clear. So if you have any question, just letak dalam Telegram group lah. Again, Telegram ni kadang-kadang if you send it during my off hours, for example after office or on the weekend, kadang-kadang saya jawab, kadang-kadang saya tak jawab. Okay, not because of that, because it is my free time. At night is my free time. Weekends is also my free time. So I will try to answer as soon as I can lah. Kalau biasanya kalau hari Ahad, kalau hari Sabtu malam pukul 12 kamu hantar, the next morning pukul 8, pukul 9 tu saya akan cuba jawab lah. Okay. So, sorry lah kalau saya tak answer because I think okay, ada orang kata ITA tak ada ITA tak ada. Okay, let's see. ITA tak ada, nanti saya letakkan. Okay, delta, zeta, theta, eta tertinggal Okay, tak apa, nanti saya akan letak lah. Okay, saya akan buat correction dan saya akan letak untuk grup ITA. Okay, don't worry. You will not be left alone. Saya akan masukkan. Alright, so any more question on this project? Okay, kalau tak ada, let's talk about this, about the project. What am I going to do is to continue with our derivation of heat transfer. So what I'm going to do is this one. Yeah, this one. Heat transfer in thin film. Yang ini this question will be in your final exam. This one will be in your final exam, but this one will be in your assignment 9. Will be in your test 2. Okay, will be in your test 2. This one in your final. This one yang this one. Heat transfer in thin films in your finals, but not in your test 2. By the way, next week we'll have a meeting for test 2 question. So I am told that I need to prepare 1 question. Hari tu I prepared question number 1. Now I have to prepare another question. The problem here is not preparing the question, but marking the questions. Because there are about 400 students. Saya raya hari tu, dah lah, no mat pun saya kena tanda. So, I spend a lot of my time, hari raya, marking. Pantang ada masa, terluang. Buat marking je. Okay, so this is the issue lah. Hopefully test 2 ni, because there's nothing to rush, because final kita lambat, so hopefully I can go slow lah. I can go slow. Alright, so kalau tak ada, we stop there for our project. Okay, so I'll note that eta has no parameters. I will put that later. Okay, eta has no parameters. I will put that later. And now what I want to do is to do this derivation, this derivation of thin fins, thin fins. Okay, macam ni lah, macam ni. Actually, saya sebenarnya, I'm not in the best of health. I have this muscle aches, mata nak terkeluar, badan seram sejuk. I believe I'm going to have a flu. So tadi masa balik pun, was driving pun macam melayang-layang ni. Okay, so I think because this is not very soon, this is during the finals. So I think can we stop here? Okay, I need to get my medication, makan Panadol 2 biji, nak tidur sekejap. Okay, will that be okay to you?
Okay, doktor.
Okay, sorry I have to finish this early because I don't think I can, ini mata pun dah berat je ni. I can stand it anymore lah. Lethargic, letih. Alright, so that's it for today. So until next meeting, thank you very much for joining my session.
Okay, well soon, doktor.
Alright, thank you very much.
Well soon, doctor. Thank you.
Thank you, Doctor. So,
Thank you, Doctor.
Thank you, Doctor.